Um, Hello. What I want to treat today is motion, a topic in physics, which is very, very vital in every man's or women daily routines. In motion, we know that motion is all about movement. So when you move from one place to other, you are talking about motion. And in motion, we have some quantities which we use to measure the movement of human being, the movement of cars, the movement of bikes, the movement of plane or the movement of ship. So these quantities are called velocity or speed, distance or displacement, time and distance, time and acceleration. And all these, they have a unit. The unit we use to measure velocity is meter per second. In other words, the unit we use to measure speed is still meter per second. The unit we use to measure time is seconds. The unit we use to measure distance is meter, and the unit we use to measure acceleration is meter per second square. So I want to treat everything concerning this with the calculation involved in it. Now, from here now, we can see that velocity, I represent velocity with V, replace distance with S or with S and represent time with T. Here I represent acceleration with A, then I represent velocity with V, final velocity with V, and the initial velocity with U and time. Then I want to make some distinction. When we talk about velocity and speed, there's a bit difference between them as far as physics is concerned. Even though in layman discussion, we make use of speed and the velocity interchangeably. Velocity is the division of velocity is the rate of movement with time, the rate of movement, as in the distance covered. If you are walking, the distance you cover with time. As you are driving your car, the distance you cover with time. So if you talk about this velocity, you talk about direction, you must state the direction of where you are, the distance you are covering, you must state the direction. If you are covering from north to east, you specify it. You can represent this direction with angle. You can say you are making move with angle 30 degrees in terms of north or in terms of east. But speed, we don't talk of any direction. Why you mention speed, when you want to use the word speed, as far as physics is concerned, you don't use what? Direction. The same thing with displacement and distance. When you talk of displacement, you talk of direction, north, east, west, or south. But when you talk of distance, you don't talk of direction. But if you talk of displacement, you talk of direction. That is the difference between distance and displacement, and also speed and velocity. So in physics, if you want to use velocity, you use it with displacement, since both of them have a direction. If you want to use speed, you use it with a distance, which is both of them do not have direction. But in this tutorial, for the sake of you to understand it well, I will say that velocity and and the speed, they are the same. You can use it interchangeably. But if they ask you the difference, you can say velocity has this direction, while speed has not. And I will still make use of distance and displacement interchangeably. They are the same. They are measured in the same unit. Displacement is measured in meter. Distance is measured in meter. Velocity is measured in meter per second. Velocity is measured in meter per second, while speed is measured in meter per second. The units are the same. So I will, for the sake of this tutorial, I will use them interchangeably. If I mention speed or velocity, don't be confused. I'm using them as the same thing, even though I've told you the unique difference. If I saying distance, I can use distance in place of displacement for you to understand what I'm trying to teach, but they are the same, and I've told you the difference. Now, on the board, you can see that velocity is the rate of speed, is the rate of movement, Velocity is the rate of movement, which in formula we say that velocity is equals to distance all over time. Velocity is equals to distance all over time, meaning that the velocity is defined as the rate of movement, as the rate of speed, as the rate of distance covered with time. If you want to move from A to B, the time it will take you to cover from A to B is all about velocity. You check the distance, you check the length of this place, you measure it and know maybe 2 meters. And what time did it take you to cover it? 1 second. So if they ask you to calculate velocity, you can say velocity is equals to 2 all over 1, considering this formula, which the answer will be 2 meters per second. So the same thing with acceleration. Acceleration, in other hand, is the rate of change of velocity with time. The rate of change of velocity with time. What do I mean the rate of change of velocity with time? It is when it is changing of velocity with time means if a car is parked here, and the car, we want the car to reach here, reach to B, the initial velocity of the car when it is parking is 0. But if the car starts moving, the time it will reach here, the velocity may be 50. So the difference between the initial place and the final place is what we call change of velocity. It's what we call change of velocity. So acceleration is change of velocity all over time. Change of velocity per time. So change of velocity with time. Or even if the car is somewhere here, the car parked here, at a time we want to check the acceleration of the car will start moving when the car, and our checkpoint is from A. Our checkpoint is from what? A. And when the car starts here, we don't actually concern ourselves with this place. But when the car starts moving, when the car reaches here, we will now take the velocity immediately. If the velocity at this point in time is 30, we now start checking I want to start our experiment with 30. When the car reaches here, it may be now 80. Now the change of velocity is what? Now we use the formula. This one is the initial now, no longer 0, because it was 0 here and our checkpoint is here. When it is here, we now take 30, and when it reaches B, it will now be 80. Then when we check our acceleration will be initial final velocity, which is 80, minus initial velocity, which is 10, or which is 30, all over. Let's say it takes 2 seconds to cover it. So now when you all over 2 seconds, which is used to cover it, and now when you subtract 30 minus 30, it will give you 50 all over 2. When you divide 50 by 2, it will give you 25 meters per second square. That's how to calculate this. But now physics now use these two things. Velocity equals to distance all over time, and acceleration equals to the final velocity minus initial velocity all over time. You use it to drive 4 formulas, which we use regularly in calculating any problem in physics. So these four formulas are these. We generated these four formulas from this, which says velocity is equals to initial velocity plus acceleration with time by time. Velocity is equals to u plus equals to u plus at. The first formula. The second formula is this s. We use s to represent distance. Distance is equals to ut plus half at. You know that our v is final velocity, u is initial velocity, a is acceleration, t is time, s is distance, u is initial velocity, t is time, plus half, a is acceleration, t is still time. This one is the third formula we derived from this is velocity squared equals to initial velocity squared plus 2as. A and s is acceleration and distance. Then another formula, which is the fourth one, is s, which is distance, equals to u plus v in bracket multiplied by t all over time. That is the third one. So any formula you want to treat, in this topic, you must use any of them. So now let's use them one by one. Now, look at this first question that is here. Look at this first question. The first question say you may not see it clear, but you can listen. The first question say a boy moving with initial velocity 100 meters per hour accelerates with uniformly at a rate of 20 meter per second square until it attains a velocity of 60 meter per second. What is the distance covered during this period? That is the first question. Now, solving this first question, you can now see how to solve it. Now, from the first question, what is being given to us? Initial velocity, which is u, is 100 kilometer per hour. What else is being given to us? 20 acceleration is also given to us, which is 20 meter per second square. What else is being given to us? Final velocity is also given to us, which is v equals to 60 meter per second. What else is being given to us? They now say we should calculate the distance covered. What is the distance covered, which is s equals to question mark. So in this case now, so look at what has been given: u 100, a 20, v 60, and s question mark. So now from these four questions, from these four formulas, you now check. If you look at these four formulas, all these four formulas contain four quantities. Look at it: v1, u2, a3, t4. This one again, 1, 2, 1, 1, 2, 3, 4. You know, this time is still the same time with this one. Then here, v, 1, 2, 3, 4. 1, 2, 3, 4. So there are 4. And if you look at this one now, you see that out of three variables, we have three variables in when we are discussing motion, we have three variables, or four: distance 1, velocity 2, displacement 3, and the time 4. 4 quantities. So these 4 quantities now, if you look at it, you see that with this one now, we have v, u, a, t. What we don't have here is distance. So any question, you look at this question now, we have u, a, v, but we have distance. But distance is not in this first formula. So since distance is not in this first formula, and our question is demanding distance, we will not use the first formula. We check the second formula. Yes, s is there, u is there, T is there, A is there, and the T is there. Now, coming to this our question, U is here, A is here, V is here, S is here, but T is not here. Since T is not in our question, we will not use any formula that contains T. You go to the second one. V is there, U is there, A is there, and S is there. Coming to this place, U is there, yes. A is there, yes. V is there, yes. S is there, yes. So we'll make use of this formula. Now we write out the formula. V, okay, yes, we write out the formula. V square equals to U square plus 2AS. I think from this thing now, we have U is here, U is here. A is here, A is here. V is here, V is here. S is here, S is here. So this formula is the right one. Now, while we fix it, first of all, our velocity is in meter per second, right? Our acceleration is in meter per second. But our acceleration is meter per second square. But our initial velocity is not in the meter per second, is in kilometer per second. Now we now change it to meter per second. How do you change it? I have treated how to convert units in one of my videos. You can check it on YouTube channel. Now you see, you change it like this. Draw two lines, 100 kilometer over hour. 1 hour is what in minutes? 60 minutes. Then 1 minute is what? 60 seconds. Now, hour cancel hour, minutes cancel minutes, and yeah, and now here, 1 kilometer is 1,000 meter. Kilometer cancel kilometer. I treated this conversion separately on my video. You can check it. Now we now multiply out 100 times 1,000 all over 60 times 60, which is 100,000 all over 3,600. And when you divide, you now have, when you divide, you now have 27.8 meter per second. So now you have seen how I convert this. You have seen it, and I treated it as a separate topic. So now this one becomes 27.8 meter per second. So now that is what we will use in this formula. Now, starting with the formula, we need S. Let us make S subject of formula. U square plus 2AS equals to V square. Now, 2AS equals to V square minus U square. Now, S equals to V square minus U square all over A. Now, you know that our S is distance, final velocity, initial velocity all over acceleration. Now, our final velocity is 60 minus initial velocity, which is 27.8 all over 20, all over 2. This is 2A. That is 20 times 2. Now, when we subtract, we now have, and remember, this thing is square though, square. Now, when we square 60, we have 3,600 minus when we square the other one, we have 772.84 all over 40 when this thing multiply. Then when you subtract now, when you subtract the up one, you now have 2827.4 1/6 all over 40, which is equals to 70.68 meter meter, because we are talking about distance. The unit of distance is meter. So that's how to calculate the first one. Then let's quickly go to the second question. The second question says, when the brake of a moving car traveling at a uniform rate of 80 meters per second square, calculate time taken to reach the velocity. Calculate time to reach a velocity of 20 kilometers per hour. So now, in this case now, what they are asking is calculate the time taken. Now they are asking time, which is question mark. Now when the brake of a moving car traveling at a speed of this thing, it retardates. Now we have another acceleration which is negative. The sign is negative. Retardation is opposite of acceleration. When a car is moving uniformly, it continues increasing with a particular time, with a specific time, to be increased with a time interval. Then if the car wants to stop, it will continue stopping, reducing with a time interval until it stops. That is when we have a uniform retardation or a uniform acceleration. Not if a car wants to stop, the car will apply brake, it will stop, it will release the brake, the car will move on again. You see that the car is increasing, reducing, while it's trying to stop. But when we talk about uniform, if you apply the brake, you continue applying the brake so that the car will continue stopping until it stops. Not stop and increase velocity, just like how cars used to do. They will stop and increase. But in this case, it will continue stopping, reducing. The velocity will continue reducing from 10 to 9 to 8 until it reaches 0. That is when we say uniform velocity. It must continue reducing until that time. So in that case now, our initial velocity, this car is now moving, and the car is in the 200 kilometers per hour at that particular time. Now the car wants to stop. So we are checking the car. We are checking the time it will take the car to stop. So this car will start applying brake from 200. So initial time now while the car wants to stop. Now the initial velocity now becomes u is equal to that 200 kilometers per hour. Then the final velocity will now be the velocity when it stops. So, but they say we'll check the time when the velocity will reach 120. So the final velocity now when it will reach 120 is equals to 120 kilometers per hour. Now time is this thing. They are asking us time. So now that is it. We are looking now for the t. So now, and remember, what the time when the brake of a car moving, when the brake of a moving car traveling at 200 kilometers per hour, it retardates as a uniform rate. So the acceleration will now be minus because is stopping. That is opposite of acceleration. Minus. Acceleration is moving, increasing, up, but retardation is reducing. So retardation is opposite of acceleration. Retardation is when a car is stopping, and acceleration is when a car is moving forward. Now we have this. Which formula should we use now from all these formulas? We have TUVA. Which one now? This one have V is here, have U is here, have A is here, have T. Yes, we will use this first one. This first one now says V equals to U plus A T. So now Now remember to convert this since our acceleration, since our retardation, which is also opposite of acceleration, is meter per second. Now we have to convert all this unit back to meter per second. I've treated it in one of my videos. You can check it. Now this one, you still do this one for the initial velocity, which is 200 kilometer per hour. Now converting it, 1 hour is 60 minutes, then 1 minute is 60 seconds. Now 1 kilometer is 1000 meter. Now hour cancel hour, minutes cancel minutes, kilometer cancel kilometer. Now we now have 200 times 1000 all over 60 times 60, which will now give us 200,000 all over 3,600. And when you divide them, it will give us 55.6 meter per second. To give us 55.6 meter per second. Converting velocity is still the same thing. Converting velocity is the same thing. When we convert velocity, we fix it like this. It will now still be 120 times 1000 all over 60 times 60, which will give us 120,000 all over 3,600. And when you divide it, it will give you 33.3 approximately meter per second. So now I have shown you how to convert it. Go to my conversion this thing video. You learn more. So now we now have this one to be 55.6 meter per second. The other one 33.3 meter per second. Now when you fix it in the formula, we want t, right? Making t subject of formula, we now have t equals to v minus u all over a, right? When you make it subject of formula. Now our v is 33.3 minus 55.6 all over a, which is minus 8. When you subtract, you now have 22.27 all over minus 8. So when you divide, our time now becomes 2.8 seconds. Then you may ask me why minus is not here. This minus is indicating negative acceleration. Is indicating that a car is stopping. Our time can be minus. The minus sign is showing that the acceleration we are talking about is negative. So it will not affect our time. That is the simple rule. Do you understand? So please, this is all I can show you here. I need you to subscribe on my YouTube channel, please. Just subscribe, give it a thumb up, and share it. That is what you can do me if you appreciate it. Thank you so much. And I have a Facebook account too, which you can visit. The name is Chomba Power. You can visit it and you learn more too. There are still post some short videos there. Thank you so much as you continue to follow me, as you continue to watch my video and learn more. Thank you so much.